Section 8.5 is factoring x squared plus bx plus c. I can factor trinomials of the form x squared plus bx plus c. So here, some trinomials of the form x squared plus bx plus c can be factored into equivalent forms that are the product of two binomials. So far this chapter, we started off with two binomials and multiplied them into a trinomial. Here we're going to start off with quadratic trinomials and factor, which is kind of like dividing them back into their original pieces, then back into the two binomials that were multiplied together. The signs and factors of the coefficients of the trinomial indicate how the trinomial can be factored. So let's start off here by multiplying these polynomials, and we've done this so far. Lots of options. We can use a table, we can FOIL, we can double distribute. I'm going to FOIL. So I'm going to take my firsts, my outsides, my insides, and my lasts. Here, I get x squared. 7x plus 3x gives me 10x. Here, 21 for my lasts. There's a pattern here, guys. Every single time we take our first two terms and multiply them to get our firsts. We take our last two in each polynomial and multiply them to get the last term in our trinomial. We take the number parts, okay, our coefficients of our variables, as long as they're like terms, and we add them up to get our middle. So here, we multiplied 7 times 3 to get the 21, and we added 7 plus 3 to get the 10 in the middle. So we can use the fact that those numbers appear with those relationships to help us find the pieces that we would have started with if we have the trinomial. So in example 1 here, we're going to try and factor this. And we know that we multiply two numbers together to get to our last number. So we're looking for numbers that we can multiply to 15. We know we can take those same two numbers and add them to the middle number. And we want them to add to 8. So we're going to list out all of our options. Here's easiest to list out your multiples, your pairs of multiples, things that multiply to 15, and then check to see do they add to 8. So we're going to start off with 1. 1 times 15 is how I get to 15. Does it add to 8? No. Then we try 2. 2 doesn't go into 15 evenly. So we try 3. 3 times 5, does that add to 8? Yeah, so 3 and 5 here are what we're looking for. And just like above, when I multiplied to x squared by taking an x times an x, we're going to do the same thing here. So to get to x squared, we're going to take x times x. To get to 15, we're going to multiply to 15 and add to 8. Because there's more than one thing, or more than one set of numbers that multiply to 15, they also have to add to that middle. Here, 7 and 3 had to multiply to 21 and add to 10. So we found 3 and 5, and it's a positive 3 and a positive 5 because we wanted to multiply to positive 15, and then we added, since we added, our signs are both the same, and here they're both positive. So x plus 3 times x plus 5 are the factors that we originally started with. Let's FOIL this back just to double check. Firsts, outsides, insides, lasts. When we combine our like terms here, I get x squared plus 8x plus 15, which is what we started with here. So it checks, and our answer is correct. So again, we want to multiply to our last number, add to our middle number. And that pattern works here. Now, feel free to pause and give this a try if you'd like. We're looking for the factored form of r squared plus 11r plus 24. Looking here, we want to multiply to our constant, to our final term, and we want to add to 11. So we check all of our options. 24 we can get to by 1 times 24. Adds to 25, that's not what we're looking for. We can try 2. 24 divided by 2 is 12. So 2 times 12 gets us to 24. When I add those up, I get 14. Again, not what I'm looking for. Then we try 3. 24 divided by 3, 8. When I add those up, I get 11. That's the pair that I need. We also could have checked 4 times 6, which add up to 10, which isn't what we need. But once we have our pair, we can stop. I also very strongly recommend that unless it pops in your head, and the more of these we do, the more comfortable you get with them, the more likely things are just to be like, oh yeah, I know this one's going to be 8 and 3. I know this is going to be 4 and 6. This is going to be 5 and 4. Things like that. But especially for numbers that have a lot of different options, I strongly encourage you to go in order so that we don't miss any factors. A lot of times people miss 3 and 8 when they're talking 24s for some reason. So if we go in order, we check 1, we check 2, we check 3, we check 4. We know there aren't any more factors though because 5 doesn't work and we already have 6 here. So there aren't any other options. It has to be one of these or it doesn't work. But if we go in order, we know we won't miss any. So here again, we multiply to r squared by taking r times r. We multiply to a 24 by having same signs, and here they add up to a positive, so they're both going to be positive. So it's a plus 3 and a plus 8. It doesn't matter if you put the 8 first or the 3 first, because we can multiply in any order. It's commutative, so we can multiply first times last or reverse them and do the same thing. Let's FOIL here to double check. Firsts, outsides, insides, and lasts. Combine our like terms, and I get r squared plus 11r plus 24. So it checks. Again, we always want to double check to make sure that we multiply to the last and add to the middle. Same idea here in example 2. The only difference is that we have a negative 11 now. So we are going to multiply to 24 and add to negative 11. We're not going to really worry about that negative for now. We're going to treat it just like an 11 like we did on the last page. So to multiply to 24, our options were 1 and 24. Then we tried 2 and 12. We tried 3 and 8. We tried 4 and 6. We also want to add up to 11. Here, we can do that by making them both negative. Negative 3 times negative 8 is how I get to a positive 24 and add to 11. So one way that we can remember that, though, is we can still treat it like a 3 and an 8, but to multiply to 24, we're going to add. They have to have the same signs. Our sign in the middle is what's going to determine our signs here. So as long as we're adding, we're finding the sum, means we're going to have the same signs. Here they're both going to be negative, and we said 3 and 8. Okay, we multiply to 24 by taking negative 3 times negative 8, and that's how we add to a negative 11 as well. Again, if we wanted to check these, we sure could. X squared minus 8x minus 3x plus 24 if I FOIL there. Firsts, outsides, insides, lasts. Combine our like terms. Since my signs are the same, I add them up, give them the common sign, and I get back to where I started here. So, this answer here is the correct factored form. Now, feel free to pause here and give this a try if you'd like. We're going to try and multiply to 8 and add to 6. I know it's a negative 6, but we'll worry about that in our signs. So my framework here is where my negatives come into play. To multiply to y squared is y and y. Here I have a sum, so same signs, and they're both going to be negative because my sign in the middle is negative. Now, to multiply to 8, my options are 1 and 8. That adds up to 9, not what we're looking for. 2 and 4, that adds up to 6. That's our winner. So it's a 2 and a 4. Y minus 2 and y plus 4. If we check our lasts, negative 2 and negative 4 multiply to 8. And our outsides, negative 4y, and our insides, minus 2y give me negative 6y. So this checks here just like we want it to. So again, for multiplying to a positive number, we're finding the sum of our factors, which means our signs are the same. It's going to match in the middle, either positive times positive or negative times negative, and we determine that based off that sign of our linear term. Here, we're going to check, can we factor this? In order to do that, we need to multiply to 2 and add to 1. Remember, our coefficient's a 1 if it's not listed. Our only options for multiplying to 2 are 1 and 2. When we add that, we get 3, which is not what we have here. And there's no other options to multiply to 2 that are integers or whole numbers. So here we cannot write it, or we cannot factor it. We also could say that this is a prime factor, or a prime trinomial. Because again, we cannot multiply to 2 and add to 1. In example 3 here, we're going to try and factor this. So here we're still going to multiply to 15, but we want to multiply to a negative number. And the only way we multiply to a negative number is if one of our numbers is positive and the other is negative. And when we combine numbers that are positive and negative together, we actually subtract and give the sign of the bigger number. So here, we're going to subtract to 2. Multiply to 15, subtract to 2. Our options for 15, again, are 1 and 15. That subtracts to 14, not what we're looking for. 2 doesn't work, so we try 3 and 5. And when I subtract there, I get 2. Keep in mind, guys, we're going to do bigger minus smaller always. So here I get 2, which is what I'm looking for. So in my framework, to multiply to x squared is still x times x. Because I found the difference, or subtracted, I'm going to have different signs. So here, one's going to be negative, one's going to be positive. The sign in the middle always goes with our bigger number, because when we subtract, we always take bigger minus smaller, and then we give the sign of the bigger number to our difference. So here, if I gave it a plus 2, that means my 5 had to have been bigger. So here, since 2 is positive, that means my 5 was positive, and my 3 is negative. Okay, every single time we give the sign in the middle to our bigger number, even if our signs are the same, guys. So that's something that we can always do. It's a real quick check. Did I give my bigger number the sign in the middle? Okay, now should my other sign be the same, like a sum, or different, like a difference? Okay, let's factor this out. Foil this out to double check. X squared, outsides 5x, insides negative 3x, lasts negative 15 because one is negative, one's positive. Combine our like terms here and we have 2x. So x squared plus 2x minus 15, which checks. So this is our set of factors. Factored form here, I'm going to set up my framework. To multiply to n squared is n times n. Now, we multiply to 36 and subtract to 9, which means since I found the difference, I'm going to have different signs. So we're going to multiply to 36, subtract to 9. My options, 1 and 36, no. 2 and 18, no. 3 and 12, bingo. So we look here, 12 is bigger and 9 is positive. So the 12 goes with my positive, the 3 goes with my negative. On B here, same idea. I'm going to set up my framework. To multiply to c squared is c times c. I need to multiply to 21, subtract to 4. Since I'm finding the difference, my signs will be different. Options 1 and 21 subtracts to 20. That doesn't work. 2 doesn't work. 3 and 7. So when I subtract here, I get 4, which is perfect, what we're looking for. 7 is my bigger number, so it gets a sign in the middle, and I have minus 7 and plus 3. Again, we can FOIL these to double check. C squared plus 3 minus 7 is minus 4c minus 21.